Welcome to the Deep Dive, the show where we take a mountain of information and distill it down to the most crucial, surprising, and often, well, useful nuggets of knowledge.
Hopefully useful.
Hopefully useful. Today, we're plunging into a topic that, honestly, for many senior Java engineers, can feel like navigating a jungle gym blindfolded. Java generics.
Ah, yes.
Specifically, the intricate world of wildcards and type variance. It's subtle, but incredibly powerful stuff. It really separates those who just use Java from those who deeply understand its type system.
You've absolutely hit the nail on the head there. Wildcards aren't just, about making your code compile or avoiding some weird error message.
Right.
They're really foundational. Foundational to designing APIs that are robust, flexible, and most importantly, profoundly type safe. And for senior roles, interviewers, they aren't just checking if you remember the syntax.
No.
They want to see why. Why do these things exist? What problems do they solve? And how do you apply them thoughtfully, strategically, in complex, real-world code? It's really a gateway to showing you get the Java's underlying philosophy.
Absolutely. So our mission today is pretty clear. We want to arm you with the confidence and the deep knowledge you need to ace those challenging generic questions in your next senior tech interview.
Let's get to it.
We'll unpack the core ideas of type variance, demystify wildcard extends, and wildcard super. We'll dive deep into those complex generic signatures like the infamous Collections.sort. We'll explore when to use the simple-looking array list with wildcard, and even tackle wildcard capture, Java's clever trick for working around its own rules. Get ready for some serious aha moments, hopefully.
Fingers crossed.
All right, let's get started. Let's unpack this with maybe a foundational difference in Java. How arrays handle types versus how generics do. This is a classic point of confusion, right? Interviewers love to probe this one.
They really do. It's fundamental.
Okay, so imagine you've written a method, maybe call it process staff, and it's designed to take an employee array. Simple enough. Now, here's where it gets interesting. If manager is a subclass of employee, pretty standard stuff, you can actually pass a manager array directly to that process staff method.
Yep, that works.
And that behavior, where the type of the array can vary in the same direction as its element types, that's what we call covariance, right? Arrays in Java are covariant.
Exactly, covariant. What's fascinating here, though, is that while this array covariance seems super convenient on the surface, just passing a specialized group to a more general handler, it's actually, well, it's unsound from a type safety perspective.
Unsound? How so?
It creates this potential for runtime errors. Think about it. If your process staff method, which expects an employee array, now has a reference to what's actually a manager array.
Okay.
What happens if, inside that method, you try to store a plain employee object into that array?
Right. At compile time, that looks fine because the method thinks it's dealing with employees.
Precisely. But at runtime, because it's fundamentally a manager array underneath, Java will throw an array store exception. Bang.
Ah, the dreaded array store exception.
Exactly. It's a runtime check, kind of a safety net, but it means this critical type error isn't caught until your code is actually running, maybe in production. Oops.
Yeah, not good.
So this contrast really highlights the core trade-off. Array covariance gives you flexibility, sure, but at the cost of potential runtime surprises.
Okay, so that's arrays. But here's where it gets really different. With generics, it's a whole other ballgame. The type array list of manager is not considered a subtype of array list of employee. You just can't do it.
Nope, can't do it.
If you try something like array list of employees equals new array list of manager, the compiler just says no immediately.
Yeah.
Why? Why is Java so much stricter with generics?
This raises an absolutely crucial question, doesn't it? And the reason for this strictness is fundamental to Java's strong compile time type safety. Let's walk through it.
Okay.
If array list of manager could be assigned to an array list of employee variable, imagine the chaos. You'd have an array list of employee empls and you'd array list of manager.
Okay.
Follow me? Now, later in your code, you're working with empls. You could try to add a non-managerial employee object, right? empls.add new employee. This new employee might be, I don't know, an intern.
Right, but empls points to a list that's supposed to only hold managers.
Exactly. You'd be trying to store a non-manager in a list specifically designed only for managers. Total type corruption potential. So the compiler prevents this whole scenario by disallowing that initial assignment. It throws a compile error right at array list of employees equals new array list of manager.
Okay, it nips it in the bud.
It nips it in the bud, precisely because it anticipates this potential type corruption. This principle maintains what we call invariance for generics. All generic types in Java are invariant. They require an exact type match. Safety first at compile time.
So bringing this back to the interview context, you might get hit with questions like, explain the difference between array and generic type safety, or why can't you assign array list of manager to array list of employee? How do you nail that answer?
The core distinction you need to articulate is this. Arrays are covariant. They give you flexibility, but they push type errors to runtime, potentially causing an array store exception. Generics, on the other hand, are invariant. They enforce strict type matching at compile time, proactively preventing those errors from ever happening.
Okay.
Think of arrays like a flexible, open-top box. You can put managers in it, but if you later treat it as just an employee box and try to stuff a regular employee in, the box might snap at runtime because, whoops, it was actually a manager-only box.
Hey, okay. I like that analogy.
Generics are like precise, custom-molded containers. If it's a manager mold, you can only put managers in it. The compiler checks that mold's exact type from the get-go. It's all about early error detection.
Preventing bugs before they even get close to production.
Exactly. And a good mnemonic here is arrays allow anything, but lead to runtime exceptions. Generics guard greatly, preventing errors at compile time. Getting this wrong, confusing compile time generic safety with runtime array exceptions, is a huge red flag for interviewers. It really signals a misunderstanding of Java's type system goals.
Okay, super clear. So, given that generics are invariant, which is great for safety but feels a bit rigid, how do we get some of that flexibility back? Especially when we just want to read from a collection. This leads us to our first wildcard, right? Wildcard extends employee.
It does, yes, but with crucial distinctions. This wildcard extends employee. It basically tells the compiler, hey, I have a collection here. I don't know the exact subtype, but I guarantee it's some kind of employee. It could be manager, engineer, intern, whatever.
Okay, so it's like saying anything that fits the employee shape or is more specific.
You got it. And this is incredibly useful for methods that only need to consume or, let's say, produce values from the collection. Think reading.
Like a print names method.
Perfect example. If you define print names to accept a list with wildcard extends employee as its staff parameter, you can call it with a list of employee, or a list of manager, or a list of engineer. It works for all of them.
Because manager and engineer are employees.
Exactly. The compiler knows that whatever specific type that wildcard represents, it's guaranteed to be at least an employee. So when you call staff.getI inside your method, you can safely treat the result as an employee. You can assign it to an employee variable E with no worries.
Okay, so reading is safe, get works fine.
Get works fine. You can read elements safely knowing they conform to at least the employee type.
Fantastic for reading. But, and here's the common interview trap, I suspect. Can you then add an element to that array list with wildcard extends employee? Like, can I add a new manager object? Manager is an employee subtype, so it feels like it should work, but I bet it doesn't.
Your intuition is right to be suspicious. And yes, there's a very important reason why it doesn't work. No, you cannot add any element to an array list with wildcard extends employee except for the literal null.
Only null.
Only null, because null doesn't carry type information. If you try staff.addNewManager, the compiler throws an error immediately.
Why? Why is it so strict?
Because the add method's parameter type is that unknown wildcard extends employee. The compiler, being super cautious about type safety, has to consider the possibility that this wildcard represents something more specific than manager. What if it's actually a list of janitor or a list of intern?
And a manager is not a janitor.
Precisely. You can't add a manager to a list of janitor. To prevent any possibility of this kind of type corruption, the compiler just conservatively says, nope, no adding allowed on any wildcard extends T-list. It effectively makes it read-only.
It's like a one-way valve. Data out, nothing in.
Perfect analogy. Data flows out safely and flexibly, but nothing can flow in to potentially mess up the list's unknown specific type. And this is why the mnemonic extends extract read-only is so helpful.
Extends extract.
Got it. That's crucial. So if an interviewer asks, why can you read from wildcard extends T but not write? Or what's the difference between list of employee and list with wildcard extends employee? The answer is all about that read-only nature.
Exactly. It's because the compiler doesn't know the exact subtype, so protects the list by preventing writes that might be unsafe. Whatever you get out is guaranteed to be at least employee, but you can't guarantee that what you put in will fit the unknown specific type. Very disciplined, as you said.
Okay, makes sense. Now let's flip that coin. What if we need the opposite? What if our method needs to write to a collection, Or maybe accept something that consumes our type, like a predicate or a comparator.
Right, the other side of the coin. That's where Wildcard Super Employee comes in.
Yeah.
This one can sometimes be a bit trickier to wrap your head around initially.
Wildcard super employee. Okay, so this means a collection of some unknown type that is a super type of employee, like employee itself or object. Exactly. Employee or object, or maybe some intermediate abstract class if one existed. This is super useful for parameters and functional objects, things like the predicate interface.
Right, predicate has that Boolean test method that takes a T.
Yep. So imagine a printle method again. Maybe this time it takes an employee array and a predicate of employee. It loops through, applies the predicate, prints if it passes.
Okay, and I could pass it a lambda, like lambda taking E arrow E dot he gets salary greater than 100,000.
Perfect. That works fine because the predicate is specifically predicate of employee.
But what if I have a more general predicate, say a predicate of object, maybe one that checks string length? Lambda taking E arrow E dot to string dot length modulo 2 double equals 0. Intuitively, that feels like it should work.
Right.
Every employee is an object. Every employee has to string. But if my printall method strictly takes predicate of employee, it won't compile if I try to pass my predicate of object, will it?
It won't. And that's again because predicate, like all generics, is invariant. There's no direct relationship between predicate of employee and predicate of object that the compiler recognizes for assignment.
Even though employee extends object. Huh.
Right. So the fix, and this is where Wildcard Super is brilliant, is to change printle to accept predicate with Wildcard Super Employee.
Ah, predicate with Wildcard Super Employee.
Now, you can pass your predicate of object. Why? Because when the printle method calls filter.test and passes it an employee object, that employee is being passed to a method that expects an employee or some supertype. And since object is a supertype of employee, it works perfectly.
Okay, so the predicate can be more general than the things it's testing.
Exactly. This concept, where a function expecting a general type, like predicate of object, can correctly process a more specific type, like employee, is called contravariance in function parameters. Think of it like a wide funnel. You can pour specific things, like employees, into a container designed for more general things, like objects. It's about being able to consume a type flexibly.
This sounds exactly like the other half of that famous mnemonic, the PECS principle. Producer extends, consumer super.
Spot on. PECS.
If you're putting things into something where it's consuming your type, like that predicate, you use super.
You absolutely nailed it. The PECS rule is central to designing flexible, type-safe Java APIs. It lets you handle reading extends and writing super scenarios gracefully while keeping that strong compile time safety.
And getting it wrong in an interview.
Huge red flag. Using extends for a consumer or super for a producer, it shows you haven't quite grasped the core type safety reasons behind them. So yeah, understanding PECS isn't just memorizing an acronym, it's fundamental. Especially for parameters like predicate or comparator, you almost always want Wildcard Super T there for maximum flexibility.
Okay, PECS. Producer extends, consumer super. Got it. Now we've covered the basics, extend super. But generics can get, well, gnarly, especially when wildcards mix with type variables and method signatures.
Oh yeah.
And the classic example, the one often pulled out in senior interviews, is Collections.sort. That signature is something else. It's public static generic T extends, comparable with wildcard super T void sort. List of T lists. Whew! That. Comparable with wildcard super T bit. Why?
It is intimidating at first glance. But the complexity is there for a very good practical reason. You might think logically, based on the comparable of T interface, that a simpler T extends, comparable of T would work.
Right, compare T with T. Seems straightforward.
But that would be too restrictive. Consider our employee class again. It implements comparable of employee, comparing by salary, let's say. Now, manager extends employee.
Right.
Here's the key subtlety. Manager usually implements comparable of employee, inheriting that comparison logic, not comparable of manager. Why? Because it makes sense to compare a manager to any other employee using the employee comparison logic.
Ah, okay, so manager isn't comparable of manager.
Usually not, no. But it is comparable of employee. So manager is not a subtype of comparable of manager, but it is a subtype of comparable with wildcard super manager, because employee is a supertype of manager.
Wow, okay. My head hurts slightly. So if Collections.sort just used T extends, comparable to T,
It wouldn't work for sorting a list of manager. The compiler would complain because manager isn't comparable of manager. How inflexible would that be?
Totally unusable for common scenarios.
Exactly. But the beauty of the actual signature t_extends, comparable with wildcard super t, is that it works. That wildcard super t allows the method to accept types t, where t can be compared to instances of t or any super type of t. It handles the manager case perfectly because manager can be compared using the employee comparison logic.
So that super wildcard provides the crucial flexibility for inheritance.
Precisely. It accommodates these very common inheritance patterns where subclasses rely on superclass comparison logic. It makes sort widely applicable while still being type safe. It's like those Russian nesting dolls again, layers of type constraints working together. A good mnemonic, maybe? Collections.sort needs comparable super flexibility.
That actually makes sense now. It also touches on something else often discussed at a senior level. Declaration site versus use-site variance. Java uses use-site, right? With the wildcards?
That's correct. Java primarily uses use-site variance. We specify the variance, extends super or invariant, right, where we use the generic type in a method parameter, a variable, etc. We're saying, for this specific use, I need this kind of variance.
Whereas other languages?
Languages like C# or Scala also have declaration site variance. There, you declare the type parameter itself as covariant out in C# or contravariant in C#, right in the interface or class definition itself, like IEnumerable out T.
So why did Java go the use-site route? It seems more verbose having to put wildcards everywhere.
It can be more verbose, yes. But the argument is that it gives you more granular control. Think about list T. Should it always be covariant? Or contravariant? Or invariant?
Well, it depends on what I'm doing with it, right? Reading, writing, both.
Exactly. If you're only reading, you want dot extends T. If you're only adding, you might want dot super T, though that's less common for generalists, more for things like syncs or consumers. If you need both read and write of type T, you need strict invariance. Java's use-site variance lets you specify exactly the contract you need at that specific point of use.
Be explicit about the contract for this interaction.
Precisely. It makes the API's intent clearer and arguably prevents misuse that a fixed declaration site variance might inadvertently allow. It forces you to think about the producer-consumer roles. While complex signatures like Collections.sort result, it provides arguably superior flexibility and type safety for complex scenarios.
And we saw this pattern earlier too, didn't we? With our fixed printl method. Public static generic T void printl with T array elements, comma predicate wildcard super T filter. That predicate wildcard super T follows the same logic, allowing consumers predicates that handle T or a super type.
Absolutely, and collections add-all method too.
Yeah.
Add-all collection with wildcard extends E elements. It takes the collection that produces E's or subtypes of E, fitting the producer extends pattern perfectly. These aren't one-offs. They're consistent design patterns you see throughout the JDK.
Okay, deep breath. Let's swing back from the complex end to the simple end. Unbounded wildcards. Just array list with wildcard. Just the question mark. When do we reach for that?
You use array list with wildcard when the specific generic type of the collection just doesn't matter for what you're doing. Plain and simple.
Like checking for nulls.
Perfect example. If you're writing public static Boolean has nulls with array list wildcard elements, inside that method, you just iterate. You get each element treated as object, because that's all the wildcard guarantees, and check if element nulls.
Right. It doesn't matter if it's an array list of string or array list of integer. The null check is the same.
Exactly. The specific type is irrelevant. It's like a universal adapter works with any array list, but you only get object-level access. You can't call, say, string-specific methods on the elements you get out.
So what I could make has nulls generic, like public static generic T Boolean has nulls with array list of T elements.
You could, but why bother? The wildcard version is simpler, more concise, and it clearly signals your intent. This operation doesn't care about the specific type parameter.
It communicates better.
It does. The key thing to remember with array list with wildcard is you can only retrieve elements as object, and you can't add anything except null. So the interview question might be, when use wildcard versus generic T? Use wildcard when the type parameter is irrelevant to the operation. Simple mnemonic. Question mark, I don't care what type.
I don't care.
Nice. Okay, last big concept, wildcard capture. This sounds advanced. I know you can't just declare a variable like wildcard temp. You absolutely cannot. That's a compile error, straight up. And trying it in an interview is a definite red flag.
Why can't you do it?
Because the compiler needs a definite, concrete type to declare a variable. Wildcard means some unknown type. The compiler doesn't know which unknown type it is in that context, so it can't create a variable for it. Wildcards represent unknown types. They aren't types themselves.
Okay, so if I do need to perform an operation that requires knowing the type, like swapping elements in a list passed as array list with wildcard, how do I do it?
The classic workaround, the helper method pattern.
The helper method pattern.
Okay, you define your public method to take the array list with wildcard. Nice, simple API for the user. But inside that public method, you immediately call a private generic helper method.
So like public static void swap with array list wildcard elements and I and j, and inside it just calls swap helper with elements comma I comma j.
Exactly, and the helper method is declared like this. Private static generic T void swap helper with array list of T elements in int I and int j.
Okay, but how does that work? Where does the T come from?
That's the magic of wildcard capture. When the public method calls the generic swap helper, the compiler performs this capture. It figures out the specific unknown type that the wildcard represented in the original array list with wildcard, and it binds or captures that type into the generic type parameter T of the swap helper method for that specific call.
Whoa, so the helper method does get a concrete type T to work with.
Yes. For the duration of that call, T represents the actual capture type from the wildcard list. Because swap helper now has a concrete type T, it can declare variables of that type, like ttemp equals elements.getI. It can perform the swap safely.
That's clever. It's like a translator. Public method speaks wildcard. Helper method speaks concrete type T.
Perfect way to put it. The user gets the simple wildcard API, but the type safe work happens behind the scenes in the generic helper. Remember the mnemonic. Capture the wildcard with a helper method.
Capture the wildcard with a helper. Okay, so if asked, why can't you declare wildcard temp or explain wildcard capture? This helper method pattern is the key. Shows you know the limitation and the standard elegant solution.
Exactly. It's a sign of a senior engineer understanding the limitations and how to design around them effectively.
All right, let's shift gears. Time for some live problem solving. Interview simulation time.
Let's do it.
Okay, imagine I'm your interviewer. I ask you, how would you design a utility method that needs to accept any collection of employee subtypes, but only for reading purposes? Walk me through your thinking.
Okay, reading purposes. First thing that comes to mind is producer. The collection is producing elements for my method, and the PECS principle tells me producer extends.
Good start.
So the method signature should use extends, something like public void process employees. Collection with wildcard extends employees. A collection makes it general, works with lists, set, whatever. And wildcard extends employee means I can pass in a collection of manager, a collection of engineer, anything that extends employee.
And inside the method?
Inside, when I iterate and call employees.iterator.next or use a for each loop, the element I get back can be safely treated as an employee. I can call employee methods on it, but crucially, I cannot call employees.add because of the extends wildcard, which is fine because the requirement was read-only. So yeah, collection with wildcard extends employee. That fits extends extract.
Excellent. Okay, next question. Remember that generic printall method? Public static generic T void printall with T array elements, comma, predicate of T filter.
Yeah.
We identified an issue with predicate of T. What was it, and how did we fix it for maximum flexibility using predicate wildcard super T? Explain the reasoning.
Right. The issue with just predicate of T is that it's too restrictive due to invariance. If T is employee, I can only pass a predicate of employee. I couldn't use a potentially useful, more general predicate like predicate of object, maybe one checking to string length or something completely generic.
Why not?
Because predicate of object is not predicate of employee. Invariance strikes again. So to fix it, we apply the other half of PECS, consumer super. The predicate is consuming the T elements. Its test method takes a T.
Okay.
So the flexible signature becomes public static generic T void printall with T array elements, comma predicate wildcard super T filter. That wildcard super T allows the method to accept any predicate that can test T or any super type of T. Now I can pass my predicate of object when T is employee because object is a super type of employee. It makes the method much more versatile.
Perfect. Consumer super for the win there.
Yeah.
Okay, last one, a debugging scenario. Your colleague wrote public void adall to employee list. Array list of employee list, array list of managers. They call it with an array list of employee and an array list of manager, but they get a compile error on the manager's argument. How do you fix this using wildcards and why?
Okay, this is that classic invariance problem again. You can't pass an array list of manager where an array list of employee is expected.
Yeah.
That's the error.
How to
Yeah.
fix it?
Well, we need to think about the roles here using PECS. The managers list is acting as a producer. It's producing elements, managers that need to be added to the list, which accepts employees.
Producers.
Extends, so we need to change the manager's parameter type. The corrected signature should be public void at all to employee list, array list of employee list, array list with wildcard extends employee managers.
Explain why that works.
Because array list with wildcard extends employee means an array list of some unknown type, that is, employee or a subtype. Since manager is a subtype of employee, an array list of manager matches this wildcard signature. And inside the method, when we get elements from the manager's list, they are guaranteed to be at least employee or a subtype, which means they can be safely added to the list of employee. It respects invariance, but uses the wildcard to allow the safe transfer based on the producer role.
It's nicely done. It shows clear understanding of PECS and invariance. Okay, stepping out of the interviewer role. Sometimes, things go wrong in interviews. You blank, you misspeak. What are some common red flags interviewers watch out for with generics? And how do you recover if you stumble?
Yeah, it happens. Big red flags we've touched on: covariance confusion, mixing up array variance, runtime check, array store exception with generic invariance, compile time check. That's a fundamental misunderstanding. Then PECS misapplication using extends for consumers or super for producers shows you don't get the why.
What if it's just a really hard question and you're genuinely stuck?
Don't clam up. Ask clarifying questions. Are we primarily reading or writing here? Can you give me a small example? Then think out loud. Okay, I know generics are invariant. PECS might apply. If it's consuming, I'd lean towards super. Let me try to work through the types. Build from what you do know. Showing your thought process, even if you don't get the perfect answer instantly, demonstrates problem-solving skills, which are often more valuable than just rote memorization. So to wrap up the key takeaways and really anchor this, always come back to the PECS principle. Producer extends, consumer super, getting values out extends, putting values in or consuming them. Super.
Got it.
Remember the fundamental variance difference. Arrays are covariant, flexible but runtime risk. Generics are invariant, compile time safety. For Collections.sort, remember that comparable with Wildcard super T pattern handles inheritance gracefully. And you cannot declare variables of type Wildcard, use the Wildcard capture helper method pattern instead.
Okay, solid anchors. And for practice, what should people listening do next?
Practice is key. First, try explaining these concepts out loud, in your own words. Teach it to a rubber duck, whatever works, it forces clarity. Second, get hands-on. Look for wildcards in libraries you use, or try writing your own methods using extends, supert. Feel the compiler errors, understand why they happen. Third, go back to the Java Collections framework. Seriously analyze add all, sort, other methods with complex generic signatures. Break them down until you can explain every piece. And maybe one more step for deeper knowledge. Think about type erasure.
The ghost of generics past.
Exactly. Understanding that generics are mostly a compile time check and what information is actually left at runtime, that can unlock even more understanding about why certain things work the way they do, like why you can't do new T or instance of array list string. It really solidifies the whole picture.
Great advice. Well, we really hope this deep dive has helped clarify Java wildcards and type variance for your senior tech interviews. If it did, maybe hit that like button. Let us know it was useful.
Yeah, please do. And subscribe for more Java interview deep dives so you don't miss the next one.
We'd also love to hear from you. Share your own wildcard interview nightmares or any tricky questions you've faced down in the comments below. Your stories really help everyone else who's preparing.
Absolutely. The community learning together is powerful.
Thanks for tuning in.